All right, what are we working on tonight?
Well, I don't have any. It's gonna be kind of weird. I don't have any specific problems exactly.
Okay.
But I was wondering if we could go over how to find end behavior
Sure.
and things like that.
Okay. If you have a polynomial like that, the end behavior is a function only of that. You can throw away the rest of it. So
Okay.
if I say, what happens to y as x goes to infinity, the answer is what? In other words,
Oh,
I'm ignoring all of those, and I'm only concerned with what x cubed does. Well, what does x cubed do as x goes to infinity?
Doesn't it continue to go up?
Yeah, y goes to infinity. In other words, the end behavior is defined as what happens as x goes to infinity or x goes to negative infinity. So as x goes to infinity, y goes to infinity. As x goes to negative infinity, what happens to y?
It continues to go down.
Goes to negative infinity because you're cubing a negative number.
Yeah.
So that would go to negative infinity. Now, if I had a function like this, now as x goes to infinity, y goes to infinity. But as x goes to negative infinity, because we're squaring it, y goes to positive infinity, as the chart or the graph would suggest. That's a parabola. So as x goes to infinity this way, y is going to go to positive infinity. As x goes to negative infinity that way, y goes to positive infinity also. Whereas if I were to draw the graph of the first function I put up there, it no doubt looks something like this, where we can see that as x goes to positive infinity, y goes to positive infinity, but as x goes to negative infinity, y goes to negative infinity. But the only thing you need to determine end behavior is the highest degree of the polynomial.
Right. Okay. And then
now there are some rational, in other words, what's the end behavior of something like this? Do you have to know that?
Probably, yeah.
Okay. What's the limit of this as x goes to infinity?
N1.
Huh?
So.
Which means we have a horizontal asymptote at 1. And horizontal asymptotes are what happens when x goes to infinity or negative infinity. In other words, if y is equal to this thing, well, I know that as we go in this direction, we're going to get closer and closer to the horizontal asymptote by definition. So we might have something that looks like this. And likewise, when I go to negative infinity, I'm going to get closer and closer to that same horizontal asymptote. So it's liable to look like that. In other words, the end behavior is y goes to 1, regardless of whether x is going to positive or negative infinity. And whenever you have a horizontal asymptote, that's what it's going to mean. In other words, the definition of horizontal asymptote is the thing that y goes to as x goes to both positive and negative infinity.
All right.
What other kinds of things?
Okay. And then,
Behavior. In other words, do you have to know end behavior based on the equation or based on the graph?
based on the equation.
Okay.
So.
Well, the equation will give you horizontal asymptotes. And horizontal asymptotes are always going to define end behavior. In other words, if I stick a 2 in there, what's the horizontal asymptote now?
Wouldn't it be the same?
It'd be y equal 2. It's always the ratio of the coefficients of the height.
Oh, y equal 2 for the horizontal asymptote?
Right.
Or for the vertical?
That's for the horizontal. But the horizontal is what controls end behavior. End behavior doesn't have anything to do with the vertical asymptotes. It's always based on the horizontal asymptote, which in this case would be 2. If I stick a 2 in front of there. Okay? And it doesn't really matter. In other words, I have a vertical asymptote there. I have a horizontal asymptote at 2. So this graph looks like this. It's hyperbolic looking. And now you can see the end behavior from the graph. And it is possible to cross over horizontal asymptotes. It would be possible to have a graph look like this. But then it always comes back and approaches the horizontal asymptote. So it doesn't change the end behavior if your graph happens to cross a horizontal asymptote. It doesn't change anything. The horizontal asymptote is the end behavior. That's what the function goes to as we go right and left on the horizontal axis. What is the end behavior of
y approaches infinity with a horizontal asymptote at 1?
Well, there's a horizontal asymptote right there.
At like 0?
Uh-huh. In other words, there's no way y can ever be 0. This thing, no matter how far I go left on the axis, it just approaches 0. So the end behavior for this function would be as x goes to positive infinity, y goes to positive infinity. As x goes to negative infinity, y approaches 0. It's the horizontal asymptote. And in this case, the horizontal asymptote only defines the end behavior as x goes to negative infinity, not positive. So sometimes the horizontal asymptote will only mean what it does in one direction. Whereas if I had e to the negative x, that is a reflection over the y-axis. So that graph's like this. What's its end behavior?
Wait, okay. As x approaches negative infinity, y approaches infinity.
Okay. What's the other?
And then as x
behavior
approaches...
is always both ends.
Okay.
So as x approaches positive infinity, what does y go to?
It goes to 0.
Here's a function. It's the end behavior on the right side of that thing.
You don't know?
Goes to
Approaching 0?
Goes to 0. There is a horizontal asymptote here. That's the horizontal asymptote because it fits the definition of horizontal asymptote. It's what the function does as x goes to positive infinity. Because it approaches 0, there's a horizontal asymptote there. Doesn't look like it is. I missed it first time I saw a problem like this. Then I realized that there is a horizontal asymptote right along the x-axis. I don't know what this equation would look like. That's some sort of a dampened sine curve whose amplitude keeps getting smaller and smaller as we go to the right on the x-axis. What other kinds of things about end behavior am I not covering? It's pretty straightforward, actually. It's really, what does the function do?
I think that's it.
Yeah.
I think that's like.
In other words, even if you don't look at the graphs, the most complicated function they're going to give you is maybe something like this. What would the end behavior of this be?
Whatever x does, so it would be.
As x goes to positive infinity, what's y going to do?
So sorry, I just have to think this. The horizontal asymptote is 1 to 1.
No, actually,
it to be 1?
It's not.
No?
No, there's no horizontal asymptote here. Because this power is greater than this power, you can't just take the ratio of the coefficients. It's only the ratio of the coefficients if the highest power is the same in top and bottom. However, I can ignore this and just deal with this two things. Well, that reduces to y equal x. Now what happens as x goes to infinity? Y goes to what?
Y goes to infinity.
And what happens as x goes to negative infinity?
Y goes to negative infinity.
And if I were to graph that, you end up with no vertical asymptotes because there's no way the denominator can be 0. But you have an oblique asymptote. I don't know, have you covered oblique asymptotes? You get an oblique asymptote, the numerator is exactly 1 degree higher than the denominator. And then you actually do the division, and whatever linear equation comes out, you ignore the remainder, and if this thing is y equal x plus 1, that's the equation of that oblique asymptote. But nonetheless, we know that asymptotes, whether they're horizontal or oblique, this function is going to approach that asymptote as x goes to infinity, which is the same thing as infinity. In other words, as x goes to infinity, this oblique asymptote goes to infinity. So y would also. But notice the other side of that, this asymptote keeps going the other way. So as the other half of this thing is going to approach that thing as we go to the left, and so negative infinity is the left-hand end behavior, positive infinity is the right hand.
Okay.
And in general, if you have something like that, that's the solution, is to just reduce it down. In other words, if I have something like this and then a whole bunch of terms after it, and it's being divided by something like that and a whole bunch of terms after it, the only thing that matters is those two. That converts to x squared. Now the end behavior is positive infinity and positive infinity.
Okay. So just the first two.
It's
And then
the
for
highest
horizontal
degree.
asymptote, the
Highest
ratio?
degree. In other words, I can have a plus x cubed, plus x squared. None of these matter. It's only the highest degree that you take into consideration when talking about end behavior.
Okay. And then when you're talking, sorry, just one more time just to clarify. Talking about the horizontal asymptotes, it's the ratio between the two, right?
Talking about what? I didn't quite hear you.
Oh, the horizontal
Horizontal
asymptote.
asymptote, yeah. If I have, it's the ratio between the two only if these are the same. In other words, if I have this, that horizontal asymptote's always 0. If the bottom is bigger than the top, the horizontal asymptote is 0, which means the end behavior would be as x goes to infinity, y goes to 0. As x goes to negative infinity, y goes to 0. Because this is the same as 1 over x. But if the top is precisely 1 bigger than the bottom, then you end up with an oblique asymptote that is a straight line. It's just at an angle. Basically, it means you're always dealing with y equal x if it's exactly 1 higher, which means your end behavior is positive infinity as x goes to the right, negative infinity as x goes to the left. And the only other situation is if x is the same, you have something like this. Now the horizontal asymptote is where?
At 3 over 2?
Exactly.
Yeah.
The ratio of the coefficients, as long as these two have the same exponent, and they're the highest polynomial. They're the highest term of that polynomial. Again, it doesn't matter what else is following this. I could follow that with a million x to the cube, wouldn't matter. This rules. You think of any other kind of end behavior functions that might give you problems.
Wait, I'm trying to think now. I think.
Does that have behavior?
What?
Does that have an end behavior?
No, but it.
There's no asymptotes, there's no horizontal asymptotes, and it doesn't approach a single entity as we go to the right. It fluctuates between 1 and minus 1. So there's no right-hand end behavior, there's no left-hand end behavior. So it's always fluctuating back and forth. Remember, the end behavior they're looking for is what y does as x goes to infinity on either side.
Okay.
How about, no, none of the trig functions have end behavior. So don't need to talk about those. Polynomials and rational quotients are the only ones I can really think of. Other than e to the x, you have some exponential equations. Y equals, how about 2 to the x? What's the end behavior on that?
I'm trying to think of what the graph looks like. So.
Well, rather than trying to picture the graph, picture what happens to this thing as we make x get big. What happens to y?
Goes way up.
Okay, so the right-hand end behavior is y equals infinity. what happens to y as x gets negatively big? In other words, as x goes to negative infinity, what is y going to do?
Does it approach 0?
Uh-huh. This curve looks just like all exponential curves. They're pretty much indistinguishable from e to the x. Okay, but I can see that the right-hand end behavior, y is headed towards infinity. The left-hand end behavior, y is getting closer and closer to the x-axis as we go further and further to the left. Why is that? Well, notice that if x is negative, we have 2 to a negative number, which means 1 over 2 to a positive number. So as this gets big, this gets towards 0. What else? Any other specific questions? I can't think of anything else to talk about in behavior other than exponential functions. Your sound is breaking up. I think you said something, but I didn't hear what it was.
Uh-oh. Is it back?
Yeah, it is now.
A little bit.
Luckily, it only has to survive for another minute.
I don't know. I just said that. I was just saying that end behavior was the only thing I didn't really understand.
Okay.
So.
Yeah. In fact, my GoToMeeting says you're offline right now. Can you still see my? Oh, now you're online again. Yeah. It actually took you offline for a moment. So. All right. Well. You good to go?
Yeah, I think so.
We'll talk to you next Tuesday. How'd your ACT go? Or you took the ACT, right?
Yeah, I took the ACT. I think it went well. It didn't really feel that hard. The time crunch was like the only problem that I had, just because it got like
so
real
the
squishy.
practice problems we did were of similar degree of difficulty?
Yeah, definitely.
Okay, good. It's good to know. You haven't got your score back yet, have you? Your sound is cutting in and out.
3 weeks after it gets to the testing center, and they didn't tell me what.
Okay. Sorry I didn't hear anything you just said, but I will talk to you next Tuesday, okay?
Okay.
All right. Bye-bye.